Okay, I'm back. There we go. Alright, now a couple of you stuck around from previously. That's okay. Okay, so just back from. Alright, we'll start in a few minutes here, so that's perfectly fine. No problem. Whew. Haven't had my full breakfast yet. Little Dunkin' Donuts. This is Math 090 pre-algebra. Wow. You're definitely in the right place. The title of the class is also in the stream description there, stream info. So if you're never sure, I always try and update this, the stream info there. So that way you know that what class I'm teaching at that time. Cool. All right, we'll wait a couple more minutes. We'll wait another minute or so, and then we'll go ahead and get started here with new stuff. All right, hello, hello, hello. There we go. Hopefully everybody's doing well today. Good. Happy to hear that. Excellent, excellent. Glad you're doing well there, my friend. All right. Well, let's go ahead and okay, 11 o'clock. Okay. Okay, let's go ahead and get started here for today. Welcome back to Tuesday. Hopefully, have a nice weekend. All right. So today, uh, we're gonna continue where we left off from last time. Last time we did a couple sections there, 1-1 and 1-2. All right, so today we're going to do sections 1-3 and 1-4. I didn't get through everything in 1-4 from my last class, so I'll probably I won't stop halfway. It just depends on how fast we get through it. I may show a couple more examples that I didn't get to, but nonetheless, I want to keep both classes here on the same pace. So, but I will show off a few more examples there, and we may do. I'll probably do another example there for next time as well. So that way it kind of reinforces the point here for some multiplication type of problems. All right. In any case, all right, so let's go ahead and get started here for today. Starting with, again, just as a friendly reminder here, remember that you can find your notes here on D2L. We're gonna be doing section 1.3 first, okay, and then we'll be doing section 1.4 as well. In between on the notes, they talk about sign numbers in chapter 9. We're not going to be doing those until later, so yeah, you don't have to worry about those just yet. When we get to them, then certainly I'll let you know, and then we'll do them. So, all right. All right. Nice. All right. So, first things first here, let's talk about section 1.3 in subtracting whole numbers. Okay. So, if we subtract whole numbers, there's some keywords here that talk about whole numbers. The keywords here being minus, difference, and less. So you'll see in word problems here, you'll see less, minus, difference of some variety, how much more is something compared to another, whatever the case may be. Now, let's talk about the keys to subtraction. And so I put down here the key to one of the keys to subtraction here is, if necessary, borrow 1 from the next column to the left. Now, let's go ahead and take a look at a couple of examples here, and we'll see where we don't borrow 1 from the left and where we do. Okay, so let's go ahead and take a look at this, and let's see exactly what we're working with. Okay, so I'm going to go ahead and use an example here from the book on page 13. So I used this in the last class, but I'll use this again anyway. So let's put this down. Okay, so we're going to have 429, all right, minus 318. Okay. Good morning, Samantha. I hope you're doing well. So we have 429 minus 318. So all we're going to do straight up is just go ahead and look at each column. Again, we're just lining up the numbers. All right, just like we did last time for addition, you got to line up the numbers and then, appropriate, just say, hey, I got to add up these two numbers together and do all that jazz. Like, okay. For subtraction, same thing. We'll line up the numbers. I do 9 minus 8, which is 1. And 2 minus 1, which is also 1. And 4 minus 3, which is also 1. So your final answer here for this one is 111. Okay, so not too hard to figure out. Again, we just line up the numbers. We can see that 9 minus 8 is 1, 2 minus 1 is 1, and 4 minus 3 is 1. And then that's what we got there at the end of the day. All right, so if we have an example like this, this isn't too hard. Again, you just basically do straight up subtraction. All right. But now let's take a look at a few other problems here, and let's see exactly how we can tackle those. So select all this and dump this. Okay. Now, so what we're going to do here next is let's try another example here, but this time we have to borrow. All right. So let's make up some numbers here. So all right, so we'll go with 300 and 57 minus 189. Okay. So let's say this is our problem right here, and we want to subtract these two quantities here by hand. Okay, so we see here that the number on the top in this column here is less than the number here on the bottom. So 7 is less than 9. So we can't really subtract 7 and 9 together. Instead, what we do is what's the key here in this case? So let me go back here for example. The key here is to basically borrow 10 from the next column over. So if I take this 5 here, let's say not 5, pardon me, let's take the 7, I'm going to make that a 17. And then I just go ahead and say, all right, I do 17 minus 9. And 17 minus 9 is 8. Okay. Now, to be fair, you're like, okay, 17 minus 9 is 8. Fair enough. But there is a consequence for borrowing 10. If I borrow 10 from, I have to borrow 10 from the next column to the left. So I borrow 1 from the next column to the left. So instead of 5 that I have here, suddenly this 5 now magically becomes a 4. Okay? So because this column here now becomes from a 5 to a 4, I then go ahead and try and apply the same rules. Well, 4 is less than 8, so I need to go ahead and make this a 14. Now I do 14 minus 8, which is 6. And then since I have to borrow 1, another 10, this 3 here now becomes a 2. And so here I get 2 minus 1, which is 1. And so here we built upon our answer here. We get 168. There you go. Remember, you got to borrow that 1 there because you made that a 14, right? You got the 4 originally, but then you had to borrow 1 because 4 was less than 8 here on the bottom. So just be a little bit careful about that so you don't mix that up. And that's how we get our final answer here of 168. All right, so before I move forward here with the next concept here in subtraction, are there any questions about that so far? Again, type no in the chat if you don't have any questions. Otherwise, if you do have a question, please go ahead and type out your question. No? Okay. Yeah, I can do that, Samantha. No problem. I'll send that over to you after class. No? Okay. That's perfectly fine. Okay, so let's go ahead and try another example here. All right. So let's try another example here, and let's see what we're working with here. All right. So this time here, we're going to go ahead and look at the next example here is going to talk about the exception to the rule here when it comes to subtraction. So let's talk about this exception. The exception says is that if I have a 0 in the column to the left, then we have to change the 0 to a 9 and borrow 1 to the left of that column. So what exactly does that mean? Let's look at an example and let's see what we're talking about. Okay, so I'm going to borrow an example here from our notes. All right, so I'm just going to go ahead and skip around here. So I'm going to use this. I used this in the last class too. So I'm going to do 4,000 minus 1782. Okay, so let's do 4,000 minus 1782. All right. So here's our problem right here. Now, what's very important here to note is what's happening here at the very beginning of the problem. We're starting from the right, like we do for all subtraction problems. And we see that 0 is less than 2. So we indeed are going to make this 0 here. We're going to make this a 10, just like we did in the last example. So now we have 10 minus 2, which is 8. Okay. Now we did have to borrow 10 from the next column over. Now let's go back to our exception here. So I have a 0 here in the column to the left. So because I have a 0 here in the column to the left, I'm going to go ahead and make this 0 here a 9. All right, so now that 0 becomes a 9. And then I have to borrow 1 to the left of that column. So I now have to change this 0 here. What should I change this 0 to be? So if I were to look at this, right, What should I change this 0 to be here in this case? Okay, so I have a 0 here. This 2 has to change over to 9. That's correct. That's right. The answer here is 9. That's right. Okay, so just be a little careful about that. This 0 here to the left now also has to change to a 9. But once again, I had to borrow 1 in order to do that. So what else do I have to do? What else do I have to do here once I've changed that to a 9? Okay. Right, exactly. Change that 4 to a 3. Absolutely right. Spot on. So this 4 now becomes a 3 because we had to change this 0 to a 9. So by using the exception here, because we had to change 0 to a 9, we have to borrow 1 to the left of that column. So we can keep going as many times as we need if they were all zeros, for example, for a long time. So we may need to keep borrowing over and over and over again until like that very first number there. That's certainly possible. Okay, so I wanted to show off this problem because we're using it multiple times, this particular exception. And that's what we want to talk about here very specifically. Okay, now let's take a look here at the rest of this problem here. So here we have 9 minus 8. 1. Why wouldn't we borrow from the 4 to start with? Well, the reason is because we have to factor in everything else to the left of that start. So good morning. Remember, we're starting from the right. So if we're starting from the right, we have to work our way over one digit at a time to the left. Okay. So one thing to be careful about, Samantha, is to, again, we may or may not borrow that 4 from the start. Let's say, for example, here, Samantha, this happened to be, instead of a 0, this happened to be a 9. Okay, 4,900, for example. Well, that 9 becomes an 8, and then you'd have 8 minus 7, and you wouldn't borrow 1 from the left of that. So you can't make the assumption that that necessarily is going to be true for every problem. That's why we want to work our way from the right and just go left and see if we do have to use the rule or not. Okay, so that's the one thing we need to be careful about in a lot of math problems is we can't. All right, so I'll make this. Um, I'll make this. We can make this assumption here. We get 2218 here. So and I'll go ahead and add this as a note here because again, I'll probably say this often for a lot of different concepts for everybody because if there's one thing that people have an issue with when it comes to good morning. Um, uh, if there's one thing people have an issue with when it comes to mathematics in general is that do not assume. So one thing about math is that you don't assume, and that's really difficult to do. Is like you just assume something's going to magically happen, and it may not work the same way because, as you can see here, especially even in something like subtraction, there could be an exception to that rule. So we take a look at we basically kind of react instead of make the assumption, be like, all right, this is going to happen. Like maybe, maybe not. So we react to see what we have in front of us and then go ahead and make adjustments as necessary. I would say that um, this really helped me out because that was one of my biggest problems when I was doing math is just I made assumptions that it's always going to work the same way every single time for every single problem. But unfortunately, I can't. Unfortunately, in math doesn't allow you to do that. You can't generally make a blanket statement for every type of problem is going to work necessarily the same way because of possible little details and little exceptions. So when I dropped the idea of making an assumption for a problem, Then I started to look at problems case by case, and then I started to see, oh, okay, there's a generic pattern, but then I have to be careful about those little small details so I don't fall underneath those traps. And that's really, really difficult sometimes to do. But that's what we kind of want to work out of, is work out of those traps there. So we don't want to fall for the same things over and over and over again. Oh, I hope that makes sense there. I know I kind of rambled on a little bit about that, but it is one of those things that I stress on here is like, hey, why do we struggle at this subject? Okay, let's not fall for the same things that we've talked about before, right? So I wanted to, I just want to kind of express that there for you guys to understand. Are there any questions about that? Okay. So again, I just hope that that makes sense there, where it's not like overwhelming or things like that. I just never make an assumption. Just see what you got in front of you. All right. Let's go ahead and take a look here at a couple of problems here for applications. All right, and we're going to use this little chart here, and we'll talk about something that I mentioned here in the first class. So for those, I know there's a few people that I know that maybe there's like one or two that stuck around from the first class there. In any case, no matter. Um, let's go ahead and take a look at this first one here. It says use the table to find, on average, how much more a person with an Associate of Arts degree earns each year than a person who is not a high school graduate. Okay. So the question is, how could we go ahead and find this? What should we do? How much more a person with an Associates of Arts makes than a person who is not a high school graduate? How can we set up that problem here for this particular guy? All right, 40,200 minus 71,900. All right, be a little careful there. So we say how much more that they make, right? I.e. the difference. So the numbers are correct, but they're reversed around. So start off with the larger number there first. So we have 71,900. And then we subtract that from 40,200. So you kind of, just go ahead and put that larger number there first. So it says, how much more does a person with an Associates of Arts compared to a high school graduate? Yeah, just go ahead and put the larger amount first and then put the smaller amount second. So the numbers are correct. Just make sure you put that in the right places. You want to have generally, we want to have the bigger number here first. So just letting you know how that works out. So if we do that here, we get 0 and 0, 7, 1, and 3. Okay, and that's correct, 31,700. I got this question from the last class, by the way. If you want to go ahead and put those commas there, like we talked about last time, if that helps you organize your things, then please go ahead and do so, and that's fine. Again, we're just lining up the numbers there, so if it helps you line up the numbers, cool. If not, okay, that's fine. Okay, let's look at letter B here. Letter B says, how much more does a person with a bachelor's earn than a person who has an associate's? So, a person with a bachelor's than a person with an associate's. So what should we do there for the second one? All right, very good. Good, good. So 100,000 minus 71,900. All right, good, good. Now, remember what I would like you to do here. So I do want to stress one thing here. One of the things that I would like you to do is to show me how you get that answer. Like anybody, like you could put this in the calculator, that's easy. But you remember, you also have to show me how you got that answer there. So one of the things I'll require you to do for a test here is to show me how you got your work. Show me how you got your answer. So again, the process here is very important, so you get used to doing some mental math as well. So one of the purposes of the course is to do so. In this particular case, we have 10 minus 9, which is 1. All right. What comes next here? Because I have 10 minus 9. The first two are zeros, so those go away. We have 10 minus 9, which is 1. What happens here for these next guys? Okay. 0 turns into a 9. Okay, so they make that a 9. I agree. All right. Now, if I made this a 9, what else do I have to do? Okay, good. We're going to turn this into a 9 as well, because we had to borrow. Once again, we had to change that 0 to a 9 using the exception to the rule. Okay, what else do we have to do then? Yeah, turn the 1 into a 0, that's correct. So we're borrowing each time down here. So then this will justify the answer here, where we get 9 minus 1, which is 8, and 9 minus 7, which is 2. So this is the kind of work that I'm kind of expecting for a problem like this. Okay, so like I said, it's easy to get the answer, but again, I want you to show me the work about how you arrive at, say, 28,100 at the end of the day. Okay. So I just want to be sure that make it clear, be like, oh, okay, you know, I didn't come up with this magical answer out of nowhere. No, this came from just doing the work here in order to arrive at that final result. Okay. Any questions so far? No? Okie dokes. No problemos. Alrighty. Okay. Now, one of the things that's actually really interesting about a problem like this is that these talk about the average earnings of a person who has an education. Now, the problem is that if you're not a high school graduate, your average earnings is $40,200, which in reality is really not true. All right, I would suspect that it would be much lower than $40,200 in terms of what you would get out on the open market if you did not have a high school diploma or GED. The problem with this is that with numbers in general, especially like data sets like this, the problem is the word average. Average is not a good indicator of what exactly you'll get in reality. The problem with averages is that if you have a very large value, so let's say you have a lot of small paying jobs if you're not a high school graduate, right? So let's say you're not a high school graduate, you get a lot of small paying hourly wage jobs or whatever. You could make $20,000. You could have five people make $20,000 and one person make $120,000. That will make the average skew in the direction of the person who made like $100,000 or $120,000. That person carries much more weight than the five people who make $20,000. So that doesn't properly reflect the actual realistic salary that you'll make. In fact, if you want to look at much more realistic salaries, depending on what subject that you want to go into, you want to, excuse me, you want to go and look at the median salary. And you probably have heard of median before, maybe way back in the day, but why is median better than average? Well, median takes all the salaries of all the people who say don't have a high school degree or have a master's or whatever, and they look at the middle, they look at the very middle person, right in the middle between all those salaries, and they say this is the median salary. This is the most realistic value that you can get. So basically, the ones on the extreme ends don't really affect what's in the middle at all. So a median salary is much, much better. So it gives you a much more realistic expectation when you actually go out there and use stuff in the real world. All right, so let me give you an example here real quick. I'll put that in. So let's say the median salary for a nurse, okay, just a nurse. So, and there could be median salaries for nursing. What's a median salary? All right, the median salary here is 67,490. Okay, so that's a median salary for a nurse. It's very demanding though. This is from 2015, so this is quite a while ago. But again, this can vary state to state or whatever the case may be. But again, it's much more realistic than maybe say something different. So than the average salary. So that's maybe not as realistic as you think it is. All right, so I just kind of want to show that off here as why numbers can be a little deceiving in that regard, and what you should take on there. Okay. All right, let me make this selection here. All right, any questions so far? Okay. All right. So that is about subtraction there. Okay. Let's move on to the next part here, which is multiplication. Okay. So the first thing I want to talk about here in regards to multiplication is this is section 1.4. Again, in the notes here, just to let you know, the next section is 9.1 and 9.2. We are skipping sections 9.1 and 9.2. We will come back to those in regards to sign numbers. I just figured I did this last semester and I was like, I did this and I'm like, sign numbers made things a little more confusing. I kind of want to stick to the basics here first and then kind of work with sign numbers after that fact. So let's just start off with something simple with the basics and then kind of work our way up. So we'll come back to chapter 9 here later on, but not for right now. We'll talk about that later once we get a little more comfortable with more of the fundamentals and where these can be useful. So we're going to be skipping those two sections there. So we'll go straight to 1.4. Okay, so in multiplication, let's see here. Where are we? Oh, there we go. All right. So in multiplication, we do have some keywords here. Some keywords here for multiplication are, say, product or multiply. All right. So again, it's not too bad. Let's why have you done this to me? All right. So I'm like, okay, sure. Sorry, everybody. It's been one of those days. No, stop doing things. All right. There we go. So we have product and multiply. All right. So no problem there. All right, now what's the key here into doing multiplication? The key here, as I wrote out, is to memorize or try. Again, try. I don't say it will happen, but try to memorize the multiplication table up to 12. Okay, so try and memorize the multiplication table up to 12. Now, what does a multiplication table look like? Let's go ahead and bring it up. So I should, oh, I do have it. Okay, I just separated it out. All right, so here is a multiplication table. Typically, multiplication tables go from 1 to 10, or again, 1 to 12, as you can see here. So you can see here, again, you multiply by 1, you go all the way up to 12. All right, so you can see like 12 times 5 is 60, or whatever the case may be. Now, this multiplication table here, or again, is going to be very helpful for a lot of different concepts that we're going to be doing. Especially when we talk next about division, this multiplication table will certainly be very helpful here. So one of the things why I say to memorize it, and try to memorize it, I should say, is because the homework for today 1314. So so what was it? Yeah. So we're going to be using the multiplication table here as as a way to kind of reference some of the things that we'll be doing calculations with when it comes to, say, division and whatnot. So taking a memorization of this will be very helpful to doing faster calculations. The reason why I say to try to make the process here faster. Trying to, not trying to skip steps or anything, of course, but you try and make it faster by doing mental calculations, because certain concepts may require many moving parts or many steps. So sometimes it'll just be faster. Now, am I suggesting you try and automatically make it faster? No, that's why I say to try. That's why I say to try and not necessarily to, uh, you know, to try, basically, because again, it's at your own pace. I've said before, make sure you solve problems at your own pace where it's not overwhelming. I still stick to that point, and I want to be sure that that you understand that. Okay. Um, so do I allow multiplication tables for tests? So yes. Okay, so I'll actually answer that publicly here. Yes. Okay, so you can use multiplication tables here for tests. Just remember, if you do advanced concepts, you'll be doing a lot more with multiplication tables and stuff. So getting to memorize those over time will be very, very helpful. All right. So, but yes, you can. Yeah, I got that. Ooh, excuse me. I got to ask that in my last class, and yeah, I'll still say the same thing there. All right. Okay. Perfect. Are there any other questions before we move on? I'm gonna go ahead and do some examples here. So, or actually show off some things. Okay. Okay. All right. Next, let's go ahead and take a look at some examples here. Again, if you have a picture of your multiplication table, that'll be helpful. All right, like I said, we'll just ease this in here. We're going to first talk about how to do multiplication here. One of the keys to multiplication, it says use the crossout rule, but we'll talk about that here a little bit later. I first want to talk about some of the basics here behind multiplication that will be relevant for what we're going to be doing here later on in this section and other sections as well. So let's go ahead and discuss those first and see exactly what we're working with. All right, first things first here. Let's talk about what factors are. Okay, factors are number or numbers when multiplied make up the final product. Okay, so when we multiply two numbers together, it makes up the final answer, the final product. So in this case here, I said, okay, if you have 8 times 5 is equal to 40, your factors are going to be 8 and 5. And when you multiply 8 and 5, your product here is 40. Not too hard. We will be looking at factors, more importantly, prime factors. All right, once we can take like 40, for example, and break it down into its prime factors, and we'll see exactly where that's going to be relevant in other topics. So this is just looking at basic factors for right now, but again, we'll be using it in some form or capacity later on anyway. Okay, so we certainly have that. Okay, now the next part here, we can also talk about properties of multiplication. Is multiplication follows the commutative property. Now we talked about that here in addition. So we talked about addition here. We said, okay, if I took two numbers, a times b, like say, as it says here, 2 times 5. 2 times 5 is 10. Now if we reverse the numbers around, I said 5 times 2. Well, that's the same exact answer. Okay, so if I take this and I, flip it around, I get the same result. It doesn't really matter. So it does follow the commutative property, and that's perfectly fine. Now, now the next part here I write specifically because there's a lot of ways to represent multiplication when written out, and I want to be sure that you guys understand that whatever I write out, however I write multiplication, that it does indeed imply multiplication at that level. So I want to talk about the ways to write multiplication here. Okay, so let's look at the ways to write multiplication. So you'll see some certain ways. You'll see A star B or A dot B. That's another one there. Is A times B. A times B here with a cross in the middle, so you've probably seen that a few times. A times B with the parentheses around, say, one of those numbers. Same thing here for number 4. Maybe the parentheses are around the second number. Or you have sets of parentheses around both numbers. That's another way to write multiplication. So again, there's 5 different ways to talk about how multiplication is written out, and you can see how that is how that's done there in that particular case. All right. Let's go ahead and go over the next one here, the property of 0. So if we take 0 times any number, that's going to be 0. If we take if we flip it around, take that number times 0, well, that's going to be 0. So 0 effectively zeroes out everything in multiplication land. It literally basically makes it nothing. Yeah. All right, next is the property of 1. All right, so you have 1 times a number is still going to be that same number, or that number times 1 is still going to be that same number. Effectively, 1 effectively does nothing. It leaves the number alone, and you get the same thing back. So 1 times 5 is 5, and 5 times 1 is 5. So, yeah. Okay. Let's talk about properties of tens, and I have a couple examples here, but I'll show off and show you on the paint tool here how this works. So, properties of tens. If you multiply by a power of 10, so for example here a 10 or 100 or 1,000, okay, just add the amount of zeros to the end of the number after multiplying the other numbers together. So if you take 55 times 100, you take 55 times 1, and then tack on the 2 zeros, the number of zeros here, which is 2 zeros, and you get 5,500. If you have 12 times 80, we have 1 zero here, which is the 10, and then we just take the other numbers and multiply them together, the 12 times 8, and then we get 96, and then tack on a 0 here at the end. Let me go ahead, so we add 1 0 to the end. Now, I'll show you another example here because this one was written from the last class. So I want to do another example here so you can see exactly how things work out. So let's try, yeah, I'll try here. We'll try, no, I don't want to do that. Yeah, I'll do that. So we'll try 11 times, 11 times, 80. No, I picked 80. Let's put 11 times 70. Let's go with that. Okay, something nice and simple. Okay, I'll go with 700 actually. I'll do it one more step. 700. Okay, so 11 times 700. Okay, so how many? So let's answer this question here. How many zeros should I put at the end of the answer? How many zeros do I need to put at the end of the answer? Okay, 2 zeros. Yeah, right? So we're going to have add 2 zeros there. That is correct. So we're going to add 2 zeros there at the end of our answer. So what we're going to look at here is just the numbers themselves. We took care of the 2 zeros part. So we're like, effectively that's done. We're just going to look straight up at 11 times 7. Okay? And once we figure that out, we're going to add the 2 zeros there at the end of that. So take a look at your multiplication table, because 11 is on there. I guarantee that. What is 11 times 7? Okay. Well, that's okay. That's why I have the replays for you there, Bill. All right. 77. That's correct. All right. And then we just tack on 2 zeros. And so our final answer here is 7,700. Just like so. All right. Are there any questions about that? Hopefully that makes a bit more sense there. But that's not too bad. It says that there's no homework on MyLab Math. Well, there should definitely be homework on my math lab. I've got to hit the homework tab there. Did you guys see homework on your My Math Lab stuff? Okay. Okay. I was no, cause I mean, okay. I just had to make sure that I set it up there, and then you saw the due dates and stuff. So yeah, it should be okay. Cool, cool. So yeah, it should be up there. All the homework there should be up there. Yeah, go for it. Yeah, absolutely. Yeah, we could talk after class. Sure, absolutely. That's fine. So I'm not sure why you don't see any homework. Remember to hit the homework section or assignment section, whichever way it says on the left-hand tab there. It always switches around. And then you should see all the assignments there, all listed for you, and click on that link. Okay, let's go ahead and yeah, I'm gonna do another couple examples here. Okay, there we go. All right. All right. So the next thing that we're going to do here is we're going to go ahead and multiply a couple of things together here. So let's see, where was that problem I wanted to do? No, that's not the problem I wanted to do. There's a particular problem I wanted to do. So, oh, there it is. Okay. So what we're going to do next here is we're going to do an example problem here of just doing some basic multiplication. So I'm going to do this one here, and I'll write that out on my little painty tool. Okay, so we're going to have here 4714. And we're going to multiply that by 8. Okay. And so we're going to figure this out here, just going slow here. We're going to go one step at a time, okay? So nothing too crazy, nothing too fancy going on here. All right, so let's go slow here very carefully, and let's see exactly what we're working with. Okay, so this is going to be a little similar to what we did for addition, just with a couple of slight modifications. Okay, so first things first here, we're just going to start from the right, go to left. So we're going to do 4 times 8, or 8 times 4, whichever way you want to read that. So let's go with 8 times 4. People like the larger number first. So what's 8 times 4 here? What is 8 times 4? Okay, 32. Okay, that is correct. So we're going to put a 2 here as part of our 32. Now this is the same way we did addition, where it's like, okay, we put that ones digit there, we're going to put it right below. No problem. Now we're going to take that 3 from that 32 and we're going to put it up here. Now, however, instead of adding all these numbers together, you're going to do this in a very special way. So I'm going to write out a little side scratch work here. So what we're going to do is we're going to take 8 times 1, and then we're going to add the 3 that we got from before. Okay, so 8 times 1 plus 3. What do we get there? 11. Good. So we get 11 there. I take the ones digit, that's 1, and I carry the 1 up here. So the next thing I'm going to do here is I'm going to do 8 times 7 plus 1. So I'm going to multiply these two together, but then add that 1 there up top. All right. 57 is correct. Okay. So 8 times 7, if you look on your times table, is 56. Okay, so remember 56 here. And then add 1 to that. That'll become 57. Okay, so we're going to again put the 1 digit down here. That's 7. And then we're going to go ahead and carry the 5 here. All right, so the last part here, I'm going to do 8 times 4 plus 5. So 8 times 4 plus 5. Did I do the 8 plus 1? Are you talking like 8 times 7 plus 1 here? So remember, you have to, so remember here, you have to multiply. Oh, you're talking this. Okay. Yeah, this is the 8 times 1 plus 3 here. Remember, you're adding what you put up top here. Okay? You're adding what you put up top here. So again, 8 times 4 plus 5 is 37. That part is correct. Okay. No, you're right the first time, Hisa. 37 was right. Yeah, so remember, what you're multiplying, let me highlight what you're doing here. What you're carrying over here, you're adding. These two guys here, like take this last step here. Like these two guys, 8 times 4 is what you're multiplying here. That's what I'm putting here on the side scratch work. So you're not taking 8 times 5. That's not what you're doing there. You're taking 8 times 4 and then adding what you brought over from the previous column. Okay, so note the difference there. There's a big significant difference there. Okay, always take your main numbers that you see in the problem and then add it to what you carried over. Does that make sense for you guys? We'll do some more examples, so of course, but I want to be sure that that's clear for everybody. Yeah, that's fine. That's fine. That's why I'm here, to clear up that confusion, okay? I want to be sure. So what do you do with the 8 and the 7? Well, I'm doing the same thing here. So like in this case, again, I'm going from right to left, okay? So I take the 8 times 7, right? And then I add the 1 that I brought over from the previous part. And then there you go. You got yourself a winner. That's where I get the 57 from, to bring the 5 over to the next column over to the left. So if it helps, okay, then something that I certainly suggest to do is just go ahead and write out this side scratch work, so like you're not caught unawares about what you're carrying over to the next column over. If you like the way I kind of did this part here where I wrote out the side scratch work here, then that's perfectly fine if that helps you keep yourself organized. Does lattice multiplication work the same way? If it's easier, to a degree, yeah. If you feel that lattice is easier, that's fine. The issue that I have with lattice, I do have one issue with lattice multiplication, because I know that's sometimes taught in schools there. The issue is that it can be really messy. So it can be messier than this process that you see up here, because you just have a lot of squares all bunched into one. Like it's like, I know you add the diagonals and stuff, and I totally get that, and if you find that to be easier, then that's cool. I got no problem with that. But the numbers can tend to be messy because you got like a lot of numbers kind of floating around all at once, whereas in this case you're just basically taking it kind of one step at a time and kind of doing it that way. So there's pros and cons, and again, I'm not going to tell you no, don't do it the lattice method way. Like, if you find that to be easier, be my guest. I got no problem with that whatsoever. If you showed me the work and says I did it via the lattice method, I'll be like, okay, that's a perfectly valid, consistent method that'll get you the same answer. No problem. So whatever you feel is best. I don't like the lattice method. That's just my preference, because I feel it's messier. I feel it's just a lot of writing. Wait, you can't get to the live stream? Press press F5 to refresh. So I had this issue in the last class, so if the live stream stalls, then hit F5 to refresh. Yes, I'll be getting that. I'll be getting to that in just a second, Samantha. Yeah, you. Yeah, I haven't done an example of that yet, but yes.